Hi there. So today we will talk about Internet of Things. What are the different elements of Internet of Things and how can we build a solution for the IoT in AWS? What are the different aspects or components that we can bring in to build some really good solution? So let's get started. Now, what is Internet of Things? It all begins with the internet. Internet, as we know, it's like a network of connected devices that is used to share information. Now, the things that happen over the internet or the kind of devices that we talk about in the internet, it can be computers, it can be smartphones, it can be wearables. So basically, it's like one of any of these compute devices that can have some kind of peripherals with which it can interact and do stuff. So since there are like all these devices that can already create a network to share information, what how different is Internet of Things? Now, the difference is that when these devices communicate with each other, they smartly know how to, to extract data from the peripherals. Like it can sense something from the environment, or it can perform an action that will actually make some kind of physical displacement in the real world. So that's what Internet of Things is about. Things talking to each other, they know what to do, and then they can take decision based on whatever information or whatever algorithm it needs to be followed. So when did IoT actually start? This was sometime in 1999 when Kevin Ashton, in one of his presentations, he was talking about how RFID could change the world by having the unique way of authenticating. So anybody who has an RFID card, they can authenticate themselves into a computer system, and that will be a unique thing. So that's how it began. And then over the years, it has been like a mix of several technologies that has come together, right from the computation, the chips getting smaller, the communication. There is like Wi-Fi, Bluetooth, LoRa, Zigbee, and NB-IoT. There are like so many different protocols that are coming into place to make sure that these devices, when they talk to each other, it's very fast, it consumes very effective bandwidth, and then they get networked in a proper way. And then it also needs to sense and act, it needs to have battery, it needs to be having a lot of security aspects. So all in all, like most of these things put together is what builds an IoT solution. Now let's talk about the architecture of an IoT system. So when we say architecture, what are the different components that gets involved into an IoT system? Now, to begin with, obviously, we are going to have IoT devices that we usually know. It could be something like a smartwatch, it could be a sensor plus a microcontroller. We put it into a wind farm, or something like a coffee pot, door lock, cart. I'm sure you might have seen some examples of smart home or smart bulb, stuff like that. So any of these devices can actually be like an IoT device that has the capability to either sense a physical environmental stuff, or it can perform an action on the environment. And these IoT devices, they tend to talk to the gateway, because most of these IoT devices, they are resource constrained. They do not have like unlimited power or the bandwidth to talk to the internet. So a gateway is like a device which most of these IoT devices can talk to, because these IoT devices may not have internet connection. So they will need something local, kind of a local gateway where all the information gets uh, collected, and then the gateway gets to decide like how can it send it to the different IoT server or whatever, wherever the data has to go to. The simplest of gateway can be a Wi-Fi router. So if you know of any IoT device, any microcontroller device that can talk to the gateway in one of the wired or wireless protocols, but the device itself may not have ability to connect to the internet. It may have Wi-Fi, Bluetooth, Zigbee, LoRa, something like that, but it may not be having internet connectivity. So probably a Wi-Fi router could be like a simplest of the gateways. It could be your mobile hotspot. or this can even be like some kind of edge computer. We will talk more about it. If we talk about edge computer, it will have more features than a simple NAT router. So that's what a gateway is. Most often, gateway and all these IoT devices, they stick together into one place. One another good example of IoT devices and gateways, like you have people use fitness bands or smartwatches these days a lot. Now, those devices do not have the capability to connect to internet directly. It connects to your smartphone through Bluetooth, and then the smartphone, it uses the internet of the smartphone to upload your wearable gadgets data into the cloud. So that's how it works. So this could be like one of those examples as well. Now, this IoT, the gateway, as it gets data, collects data, does whatever processing it has to. Further, it sends data to the server. This server could be either on the cloud or could be on premise itself if the idea is to like store data locally. Now, this is where a lot of AWS or cloud services come into picture. AWS has something called as AWS IoT Core that acts like an IoT server. So once the data goes to the server, it gets to decide like what to do with the data, and there can be a number of applications that can keep running that talks to the server, collects the information so that it can send an email notification, it can take it to the queue, it can forward it to an API, it can have like dashboards. Any of those applications, they usually talk to the server and get the data. So this is like an overview of what are the different components of IoT system. Now, characteristics of IoT devices. So these are like only the first column things, like when we have these IoT devices, how do they really work? Now, most of these IoT devices are resource constrained. When I say resource constrained, it means that it will have limited power. It may not have like AC supply. Most often IoT devices run in batteries. So power is one of the constraints. So we want to be making sure that any IoT device we design or we develop, it has to consume power very effectively so that it can last longer. And also we need to make sure that it consumes less bandwidth, because the more data it sends to the gateway or the cloud, the more power gets consumed. So we need to make sure that the bandwidth is also, we will have this constraint of bandwidth as well. Computation, again, since we have like limited power and we want the device to be very small, obviously there will be limitations in terms of computation. So we will be able to process less amount of data. So obviously it has to be compact size, it needs to be low cost. And then most often these IoT devices should be programmable and reconfigurable, which means like the first time we program it and then we deploy it somewhere in the remote site, or it could be anything, but we should always be able to like send updates over the air or program over the air, configure over the air. Stuff like that is what is very trending in IoT ecosystem now. Now, there are like different devices that are available in the market. Arduino Uno, you might have heard about it. It's like one of the entry-level microcontrollers, but it does not have the ability to connect to a network. So if it has to connect to a network, there is this Arduino 33 IoT Nano, and this has Bluetooth and Wi-Fi inbuilt. So we can use those wireless modules to connect to the internet. Similarly, there is also Raspberry Pi, you might have heard about it. There is ESP32 board. And this is my recent favorite, which is like M5. From the M5 stack company, they have released a number of IoT devices which are based on ESP32, but it has like very easy to use features to program. It comes with a lot of peripherals as well, which is like a really nice thing. And some of these devices we will actually be like configuring, working with in this session itself. Okay, and when we talk about the scope of Internet of Things, like, is this really important, or why is the world going crazy about it? Because it actually is. There's like a lot of scope for people who have the IoT skill. The way I see it is like IoT is like a wild card that works very well with several other trending technologies these days. It works beautifully with AI or ML so that it can offer predictive maintenance solutions, anomaly detection solutions, and in industry, in healthcare, in automobile, this is like a really helpful thing that's coming up. Similarly, with AR or VR, we can have like real time monitoring. We can wear a glass, or we can have our smartphones pointed to a machine or anything like that, and then we get real time metrics of that through the IoT. It can work with blockchain so that we can have like smart supply chain, and even in robotics, drones, 3D printing. There are like so many applications or so many other domains that IoT can work with in order to deliver like unique solutions, which is like a really uh, good thing about IoT. And that also makes it as important as any other field, because in most of the other fields, like, we need data in order to process, and IoT is like a domain that generates data and then it offers the data. Okay, now let's dive into what does AWS offer for Internet of Things domain. Now, uh, AWS has this concept of IoT universe, which means it has developed several services, and then it has made sure that how these services will be relevant for IoT devices at home, at work, in the community. How will they communicate with the cloud, and how can applications or APIs talk to these services on the cloud and then derive value out of it. So basically, like, the slide talks about, IoT is addressing uh, the IoT domain on the whole, not only for like one industry or anything like that. And all the IoT services, they have been categorized into three different layers. From the bottom, if we start, like, there is device software. So when we have these IoT devices, these microcontrollers along with sensors, how can we how can we connect those devices to a server where it can send the data, and what software will be running on that device? That will all be about the device software. And similarly, there is like control services. So on the server side, how do we control the data that comes in? How do I control, manage, and secure the devices? So that's how, I mean, those are the things we address in the control services layer. And once the data gets generated, we have it stored. Like, how can we extract value out of it? What are the different ways we can store the data? What are the different ways we can interpret that data and then understand it better? So these are like the three layers, but the services in each of these ones, this is how it goes. Like, on the right, you can see that device software, it has free RTOS, which is like, I mean, the microcontrollers can either run a bare metal program or it can run an operating system. FreeRTOS is like a real-time operating system that AWS has partnered, and it has like developed a lot of frameworks or a number of functions based on FreeRTOS that we can use to develop the device software. And then there is, I mean, when we don't want to use FreeRTOS, is there any other way? Yes, there is. Like, we can use any of the SDKs, depending on what platform are we talking about. If we want to, let's say, we have a microcontroller, we want to use Arduino IDE, or we want to use something like UI Flow or MicroPython. So AWS offers like the SDKs with which we will be able to configure these devices and make it communicate with the AWS's cloud services. Similarly, there is something called as Greengrass Device Tester. We will go through each of these things, some of these in detail, but the others as an overview. And then connectivity and control services. On the server side, there's obviously going to be like the server, the primary service of AWS IoT is called AWS IoT Core. That's where we uh, develop or we provision devices, and then when the devices send data, we get it to the IoT core. There's also device management, device defender, and when we talk about analytics service, once we have the data, how do we work with the data? All those comes into analytics services. Okay, let's begin with connectivity and control services. And in this, we will start with IoT Core because this is like the fundamental of the services. Now, IoT Core, it's just like one service. You can imagine it like a server, and devices, they usually send message to the core. The way it does, we usually consider it to be either publishing the messages to the IoT core, or it subscribes and it receives the messages. We will talk about MQTT and then more in detail. So basically, there are devices or clients or programs that publish and subscribe from the IoT core so that the messages gets exchanged. And also there is like device management. So how do I make sure that the communication between the device, IoT devices and IoT core is secure? So there's a mechanism of how we can register these devices, how we can group these devices so that we can have like certain permissions or policies attached to the devices so that we control what each device can do. So that's about organizing, and there is like updating. So once the devices have been provisioned, it's deployed on the job. How can, if I need to update, how can we perform over the air update? All that stuff. This is again something that device management, AWS IoT device management service offers. And then we also get to see the output, whatever data is these devices are sending to the IoT core. How can we monitor it from time to time or in a real time process? Okay. And there's also a device defender, which also comes as part of the connectivity services. What it means is that, like, let's say, how do we make sure that all these IoT devices, they are securely talking with IoT core and there is no infringement in the network? Somebody, I mean, any other device should not be able to replicate itself, or it should not behave as if it's a registered device. So there's this service called device defender. There are two ways of how we can use it. Like, we can either configure rules, pre-configured rules. We can have pre-configured rules with which we will be able to specify that if certain action happens, for example, if the device's IP address change, or if the device's IP address, when it changes, if the I mean, the location of these IP addresses, if they are like 1,000 kilometers apart, it means that something is going wrong. So it needs to be addressed and that device needs to be blocked. So we can have like pre-configured rules with which we will be able to like, it's basically like a firewall based on either our predefined rules, or we can have like a machine learning based device defender. So if we just say that the device defender has to like use all the AWS's best practices or its knowledge to make sure that our device network is safe, then it will use all the ML stuff so that it defends our IoT network. Okay, now let's dive into IoT Core. How does it work? How can we provision a device and all that stuff? Now, there are a number of things that IoT Core offers us. So the basic thing is like, we will have these device SDKs. Now, this device SDK is like the device along with the software, which is when provisioned, like it will be able to send data to AWS IoT Core. So this is like the device gateway that is running on the IoT Core service. Now, for these devices to be able to send data to device gateway, it needs to go through two processes, which is like authentication and authorization. Authentication is to make sure that the device is who it claims for it to be, and the authorization is like what permissions does this device have in the device gateway. And in all the devices that we register in IoT Core, it'll be maintained by device registry. And so once the data goes to device gateway, there are a couple of things that can happen. So what do we do with the data? Either we forward it to rules engine. So depending on what rule have we specified, it will either get stored, it will be forwarded to other AWS services or third-party services. So it can be stored into, let's say, DynamoDB, or it can trigger a Lambda function. It can uh, publish to an SNS topic. Things like that can happen from the rules engine. But we can also like store the last known state of these devices. The way we do it is like we simply forward it to device shadow. So device shadow maintains the last known state of the device that actually communicated with the IoT gateway. So when applications need to talk to the devices, they do not have to talk to the real device, because that device may not be available intermittently, because there are very high chances in IoT domain, especially, that because of power or because of sleep mode or one of those things, the device may not be available to listen for requests. So we usually like design applications such that it talks to device shadow. From device shadow, it knows what's the last known state, and that helps in a really good way. Okay, now let's see how can we register for a device and how can we work with it. Now, uh, I'm hoping that all of you know that work with AWS. So once we are in the AWS Management Console, I'm going to use North Virginia region because some of the services that we use, it's not available in India. So I'll stick to North Virginia for this one. Now, the service we need to begin with is IoT Core, and search for it. And from the services, you can click on it. It will take you to the IoT Core console. Now, there are a number of things that you can understand from the menu in the left hand side. When you click on monitor, you will be able to see what devices are currently running, how many connection requests have been made, how many messages have been published, how many rules got executed, all that stuff. Since I have not had a lot of IoT Core activity in this account lately, in this region especially, you see that there's no data available, but we will come back to it and then see. This is, by the way, like what the service, which is device management, does. So device management allows us to like have a monitor where we can see how many devices got registered, connected, all that stuff. Any recent activity, it will show it here. Okay, so how do we register for a device? We can simply click on manage, and then there are a number of things here. You can click on things. When you click on things, it will show you how many IoT devices have we provisioned. Currently, this account does not have anything. So how do we register for one? Let's click on register a thing. And then for now, I want to create a single thing. I'll click on create a single thing. And then let's give this thing a name. So I'm going to call it demo device. Okay. And we can have like the type of the thing. For example, in order to classify, for example, let's say if the thing was a bulb, we could have said the thing type belongs to a bulb, an LED bulb, or something like that. And then it will, when we define a thing type, it will automatically have some of the attributes here, and those attributes can define further for these devices that is this bulb like 100 watt, 40 watt, 10 watt, stuff like that. So that's why these types exist. For okay, let's go ahead and then do it. So I'll click on types, and then I'll click on create a thing type. Now let's say the thing type that I'm creating, it's called bulb, and irrespectively, like there has to be some kind of manufacturer for it. Okay, so this is like one of the, not the tags, I need to give it attributes. So I'll give manufacturer is one of the attributes that a bulb will have. The other thing could be like what's the color of the bulb, and it could also be having like one another attribute, something like wattage. Okay, so three attributes. And then I can click on create thing type. So this is like one of the types, and then similarly there can be thing groups as well. What's the difference between a type and a group? Type defines certain attributes of the devices, but thing groups are essentially meant to manage devices in bulk. So let's say if there are like 100 things and 10 things belong to a certain department or a building or a room, we want those 10 devices to have like different permissions, different privileges. Then we can have a policy and attach to this particular group, and all the devices in that thing group will inherit those uh, permissions. So that's why thing groups exist. Okay, I've just created a type, and then I'll go back and then create the thing. Create a single thing. Let's call this bulb 101, and this belongs to the type bulb. So as soon as I selected that, it has already automatically like put the attribute keys here. Let's say the manufacturer is Wipro, color could be like white, and what age is, let's say, 25. And we can search the devices based on these searchable attributes as well. We can have up to 3 searchable attributes, but if we want to have more attributes for a thing, those attributes will not be searchable. Okay, now that I have given the name, given some attributes, which is like optional again, if you wanted to do that, you can. And we will click on next. Now, there are different ways of how we can generate certificates that will be used to authenticate these IoT devices with the IoT Core. I'll go ahead with the simplest one, which is like one-click certificate creation, which is also the recommended option. Create the certificate, and then it shows these files. And now this is like the only time when we will be able to like download these files. So I'll go ahead and then click on download, and I will store it here in devices. Let's say certificates, and I want to have, I call this device as bulb 101, and within that I'll save the certificate. Similarly, I'll go ahead and then save the public key, and also I'll save the private key of this device. And we also need to make sure that we activate the device, which is an important thing. Now, there has to also be like the root certificate with which this certificate gets authenticated. So I'll go ahead and then click on root certificate, download the root certificate. When I click on that, it takes me to a site, and then where I can use like one of these options. The recommended one is like Amazon root CA, so I'll click on that, and I'll copy this certificate, and then I'll go ahead and then I'll store it here. The desktop, dive into AWS IoT, and then in there it had folder called devices and certificates in it, and then bulb 101 in it, and here nano root ca.pem, and so there I am putting that value, and then I'm storing it. Okay, so I have like the 4 files that came as part of the thing registration for me. And the next thing we need to do is attach a policy. So we need these certificates to authenticate itself to IoT Core. So once it authenticates, it needs to have certain permissions with which it will be able to do things on IoT Core. So where are we going to define those permissions? That's where a policy comes into picture. Currently, if I click on attach a policy, there's like no policy that's already existing. So I'll click on register thing, but we will have to make sure that we attach a policy to this. Okay, so how do I create a policy? On the left side, you can click on secure, and then there is one of the options called policies, and then you can go in there. Now we can create a policy. Let's say bulb 101 limited policy, something like that. I'm naming it, and then I can specify what actions or what permissions does this policy provide. I can say that this policy should allow the device to get connected to IoT Core. So I can click on IoT Connect. Once we click on that or enter it, it will automatically put in the resource ARN. So this will have the ARN value, and in here, like, we need to replace with the client ID. We need to put whatever is the thing name. So I'll call it bulb 101 because that's the name I have given for this one. Okay, I'll click on allow and then add a statement. So I mean, this statement, it will allow the device to get connected to the IoT Core. But if it has to like send or receive messages, okay, so this is a time when we have to talk about MQTT as well. So IoT Core has an MQTT broker in it. It's very similar to how HTTP. I mean, it's not similar, but conceptually in HTTP, what happens is like we have a server and we have clients. Clients send the request to the server, and server sends the response. In MQTT, what happens is we have an MQTT broker, and then there are going to be devices or clients that either can publish data or it can subscribe to data and receive those messages. So for example, like here, this device, which is like temperature sensor, it is sending the value 24 degrees centigrade in a topic called temperature. That's how we publish based on a particular topic. And now there can be subscribers who could have subscribed to a topic called temperature. Now, when they have subscribed it, any publisher who publishes a message in that topic, the subscriber will get that message. So that's how this thing works. And the MQTT broker can have like different authentication mechanisms. To begin with, there can be like no authentication, which is like anybody, if they just know like what's the IP address or domain name of the MQTT broker and which port it is hosted in, they will be able to easily connect to it, send data, publish data, subscribe to data, all that stuff. And there is like one more authentication mechanism, which is based on username and password. And there is like one more mechanism which is of like broker certificate. So what happens when we have like a certificate that validates broker is like whenever the device wants to send or connect to the broker, it will make a request to the broker, it will get the certificate, and it will verify that is the certificate valid. And if it is valid, only then the IoT device will establish a connection with the broker. So that is like the broker certificate validation method. And there is also something called as client certificate validation. This is what AWS IoT Core uses, which is like kind of mandatory or the only way of how any device can connect to AWS IoT Core. So what happens in client certificate is that not only the IoT device validates the MQTT broker, but the MQTT broker also validates the IoT device. That's the reason why when we register for a thing, we generate certificates, and those certificates have to go into the IoT devices. So when the device wants to connect to MQTT broker, the device will validate the MQTT broker based on the certificate the broker has, and the broker will validate the IoT device based on the certificate the device has. So that's how it works. So here we are going to use the client certificate. Okay, now the IoT device, in order for it to connect to AWS, we have specified how should it be, and then we will add one more statement. Let's say I want to publish, so I can go ahead and then select the action to be IoT Publish, and in here we need to specify what's the topic in which the device will be publishing. So let's say I'll call it bulb 101 publish. Okay, I'll allow that. Add one more statement. It could be IoT subscribe, and then I can say bulb 101 subscribe. One thing for you to note here is that when we perform the IoT connect action, the resource ARN is going to change. This will have a word called client. When we want to publish, it has topic, and when we want to subscribe, it has something called as topic filter. And there's like one more thing we need to add, which is called IoT receive. So subscribe is one of the things, and then we want to receive that message for bulb 101 subscribe, and then I'll allow this, and then let's say create. So this will create the policy. Now we need to attach this policy to the device. How can I do that? Okay, so I'll go back to things where I see bulb 101, click on that, and when I'm in here, click on security, and then it will show the certificate that is attached to this IoT thing. Click on that certificate and then click on policies. Currently it says there are no policies attached to this certificate. The way policies work is like the permissions gets attached to the certificate, because certificate is actually the thing that's like the device that holds the certificate. Anyway, so currently there are no policies attached, so I'll click on actions and then attach policy here, and then I'll click on this, and then I'll click on attach. So what does this do? It will, now this device has the permission to publish or subscribe or connect, receive everything on this device. Okay, now that we have provisioned the device, how do we interact with IoT Core? Now, MQTT has like a lot of tools. We can quickly go to mqtt.org, and then you can see that how MQTT works, a little bit of information in here, and then when we click on software, it will tell you like if you want to create a MQTT broker or a server, what are the tools that are available for you. And similarly, if you want to use cloud brokers, what options do you have, client libraries. So if we want an Arduino device to connect to an MQTT broker, how can we do that? So this is all device specific, and for different programming languages, again, there are like so many of these options. One of the things that I use is the Mosquito Pub sub in the terminal. So it's a command line tool. So just like how we can use the curl command to send, to make a HTTP request, we can use the Mosquito Pub sub tool to communicate with a broker. So let me show you. So I'll have my terminal here, and then I can do like mosquito underscore pub, which is like publish, mosquito publish. And then if I do help, it tells me like what are the things that I can do with it. What are the options I can work with? I need to specify the host. I need to specify which port number is it working in, if there is a username and a password, what topic do I want to communicate with, and there are like so many options. Okay, now let me quickly also go through this. So for a device to get connected to IoT Core, we need certain things or certain information. First one is like whatever is the thing name. Now this thing name and client ID is the same thing. And this is important. We need to make sure that we have the thing name exactly, no spelling mistake. and no case mistake as well. The other thing we want about the thing is that we need the device certificate. We need the device's private key, and we need the AWS root certificate so that it can authenticate the MQTT broker's certificate. And we need the endpoint. So this will be like endpoint or URL that has the address of the AWS IoT Core MQTT broker. And we will also need the port number. And by default, like we know how HTTP works, right? Like it works in port 80. Similarly, HTTPS, it works in 443. Similarly, there is like MQTT and then MQTTS. MQTT works in 1883 and MQTT works in 8883. HTTPS and MQTTS both have the concept of SSL certificates, and that's how they ensure that the data gets encrypted while on the move, and it has like all the code signing process and all that stuff. So the port number here will be 8883. And after this, we need to have like, if we are publishing, we need to know what's the topic name we can publish to. And then we also need the message, which is like optional. Because if we are subscribing, we will only be listening to any other device sending messages. So these are some of the things we need. Now what I'll do is I'll try to, here I have my 4 files, which is good. Okay, so I'll do mosquito publish. First I need to specify the endpoint, which is like the host. So where can I find the host name? I can go ahead and then I can click on settings in the left, and here it gives me whatever is the host name or the endpoint. So I can copy that and then I can paste it here. So the host name is done. And then we can do like port number. Port number is 8883. And then we need to specify whatever was the certificate. So I'll quickly do mosquito publish help so I get the right options. I need to specify whatever was the CA file. Dash dash CA file is root CA. And then I need to give certificate and key as well. Let me just make sure. Small p is for port. Okay, cool. Now I'll give certificate and key, CERT, and then starts with 5 certificate. Similarly, key, and then starts with 5 and then has private key. Okay, now I've given like all the information that, wait, I need to give the client ID as well. So the way we give it is like we put -c and then we give the client ID there. Disable, no. How do we specify the client ID? Okay, it's I. So we have to do -i, and then I can do bulb 101 because that's the name with which I have created the thing. Now I can give topic name. Let's say the topic name. Okay, I created the policy which is like very limited. So I can only publish to the topic name called bulb 101 publish. And then I can send a message in there. So let's say I said, hi there. Now, if all things well, it got executed, it has come back. How do I see? Is there a way we can see if the message has been sent or not? We can come back to the MQTT, I mean the AWS IoT console, and then there is something called as test in here. Click on that and then click on MQTT test client. And when we get in here, I can subscribe to a topic. I mean, for the browser to, for the AWS IoT Core's test thing to connect to IoT Core, it does not need any permission. So I can subscribe or publish to any topic from this client. Okay, I am publishing to Bug 101 publish. So I'll subscribe to that topic. When I do that, if any message gets published to this topic, it will start populating here. Let me quickly go back and then run that again. Got executed. So here it says hi there. By default, it expects a JSON packet. So that's the reason why it says like we cannot display the message as JSON because it's not valid. But I can go ahead and then I can simply do this one. The client is terminal. Now we will have like a JSON object here. Probably again, it's not UTF-8 string, but you get the idea how we can send message from the terminal to the IoT core. Similarly, let's also see how we can subscribe in here. So what I will do is like, instead of publishing, when I subscribe, I don't have to specify the message. And then the topic will be subscribe. Okay, and I will do mosquito sub. Everything else remains the same thing. So I'll subscribe. So it becomes like a blocking statement. Any message that comes, it will keep printing it here. So I'll come back and then let's click on publish to a topic. And the topic I want to publish in is called bulb 101 subscribe. Okay. And then I'll publish to that topic. Here it has got that message, whatever was in there, message hello from AWS IoT console. And then I can go ahead and then I can add some value by reskill. Okay. Now if I publish, here I have like one another message that has both of these things. Just to show you the concept of policies, I'll stop this statement, clear it out, and then I'll publish to a topic which we do not have authorization to send it to. So let's say the topic now I will try to publish to is called bulb 101 pub, not the entire publish. So I'll go back to subscribe and then I'll do pub and then I'll subscribe to it. Now, the device that holds this certificate, the private key, all that stuff, it does not have the authorization to publish to this topic. But even if I publish, we will not get any feedback in the terminal or in the device that gives us like an acknowledgement that the device, I mean, the message was not published. But if we go here, like we will not be able to see that message either because it has, I mean, IoT Core has limited that message from actually getting published in here because that device does not have the permission to publish to this topic. So that's how it works. Now, for the, I mean, for this session, we will be provisioning a number of devices. So I'll go ahead and then I'll create a policy that will have like unlimited access. So I'll create something called as allow all. And the action I want to allow is like IoT, all the actions I want this policy to have. Now, when I do that, I need to specify like what are the things it can do. So I'll get rid of this topic thing. I'll put a star here as well, and then I'll click on allow and create, which means a device to which this allow all policy has been attached. It can basically like connect with any client ID It can publish to any topic. It can subscribe to any topic. It can update the things, thing shadow, all that stuff. Okay, so I'll go ahead and then go to this thing again. And then I'll quickly go to security, certificates, policies. I'll detach this policy and I'll attach the allow all policy. Okay, now that I have done it, if I come back to MQTT test client, and let's say I do bulb 101 PU, subscribe to the topic, and then if I publish now, it will have got this message here. One thing to remember is that by changing the policy, or by having a policy that accepts all the permissions, that has, that's basically very abstract to have all the permissions, we are bypassing the authorization step, but not the authentication step. Just because we have given a policy like that, it does not mean a device without a certificate and a private key can connect to it. It will still need to have a valid certificate and a key that has been created in IoT Core in that account, in that region. Only then it will be able to communicate to it. Okay, so this was like a very quick demo of how we can work with this. We will see like with some really good examples as well. Now, you will have to hold on for a moment while we get to work with like some of these devices. Like we will see how can we use a Raspberry Pi, this M5 Stick C or M5 Core 2 or even ESP32 devices. We will get to that, but let's first see how can we work with the rules and the device shadows. So what are rules and device shadows? Because currently what we have done is like from the terminal, we have sent the message that comes to IoT Core. If I do not perform an action on this message will not be persisted. It will vanish in a, like once it receives, if there is like no rule, it will clear the message. It will not hold on to it. There will be no place where we can go back and see what are the different devices that has sent data to the IoT Core. That's the reason why we need to act on those messages. The way we act, we do it using the rules. Okay, there's like one quick tutorial that AWS IoT Core has, which explains very beautifully how we can work with that. Connect and manage. It takes us not this one. On the left hand side, you see this thing called as learn. When you click on learn, it tells you like how AWS IoT works. It's like a quick 5-minute tutorial. Let's go through it. So start the tutorial. Now, this is what a device gateway does. So basically, like it is doing, so there is this device on top, which is like a remote device, and there is a bulb. So these are the two devices. The remote, when any button is clicked on it, the bulb color changes that way. So if I click on B, a message will go and then the bulb changes its color to blue. If I click on green, G, it changes to green, and then if I click on R, it changes to red. So that's what a device gateway does, and that's what we have also been able to see now. So a device, it could have been a microcontroller, but I chose to send it from terminal. Makes no big difference. Okay, the next thing we will look into is like rules engine. So there can be a rule. What it can do is like whenever we click on the B, the rule will convert B into G, and then it will send the value to the lamp. A rule can be in either enabled state or disabled state. Currently it is in enabled state. So irrespective of, if I click on G, the bulb will become green. If I click on B, the rule will change that B into green, and then the bulb will still be green. So you can see it has become green. But if I disable the rule and then I click on B, it will become blue. So this is like one of the rules that's there. And we can have like other actions as well through the rules. For example, uh, when we click on R, there is one rule. What it does is like it sends a notification to the mobile, it triggers a Lambda function, it stores it into the database as well. So when I click on R, you can see how it flows, and then it has done all of these things. If I disable that rule, there's no connectivity for these services with the IoT core. So if I click on R, basically no message will go into this one. So we can have rule actions that can actually forward data from AWS IoT core to other AWS services or third-party services. And we can also have something called as device shadows. So whenever, let's say, the remote sends a message, and in case if the bulb is not available at that point of time because of internet, because of power, or any of those things, so I'll quickly disable this one. So this bulb is not connected to IoT core right now. But IoT core maintains what is the desired state for the bulb when it comes back by having a shadow in here. So currently it's red. I'll click on green. What will happen is like this device shadow has become green now. And when the device comes back online, which means like I just enable it, it has become green here. I'll disable it again and disable these rules as well. So if I click on, it was green earlier, right? I'll click on blue. The device shadow has become blue. And when the device comes back online, it will first talk to the device shadow and then it will update itself to the blue color. So that's how device shadows work. And we can have APIs or mobile applications that can talk to AWS IoT Core that can trigger all of these things. So we don't really need to have like a physical remote. We can even have like any application running on mobile or web application that can control these things. So let me click on G, it will make that to green. If I click on B, because that is enabled, B gets converted to G. If I make R, this also gets to working, and the right hand side also gets working. So that's like a quick uh, tutorial on how AWS IoT works. Now what we will do is like, let's say I'll go to act and then I'll click on rules, and then let's create a rule. And then in this rule, what I will do is, let's say I have a rule uh, to publish to SNS topic. And the way these rules work is like we write a SQL query. Instead of the table, we specify what is the topic name. Now, so select all the attributes or all the key in the JSON from the topic. Let's say I change it to bulb 101 topic, not publish. Okay, so get all the keys in that JSON and then I'll add an action. Since I want to send a SNS notification, I'll click on send a message as an SNS. Yep. Click on this and then configure action. And then I need to select an SNS topic since I don't have any in this account in this region. I'll click on create. Let's create the topic name to be SNS publish. Okay, I want to send it raw, and then there's no role. I mean, since SNS is a different AWS service and IoT Core is a different service, the IoT Core needs to have permission to trigger the SNS target. So we need to have a role that IoT Core assigns in order to trigger the SNS topic. So I'll create a role. Let's call this IoT Core SNS. Okay, it will create the role, it will attach the role to IoT Core, and then let's click on add action. And then I'll do create role. Okay, I'll quickly have to go create a subscription as well so I can show you how I get the email. We have created the topic, but we need to specify this needs a subscription. So I'll create a subscription. I'll say this topic, whenever it gets triggered, it has to send an email to, let's say, Sufian at things.school. Okay, I'll create the subscription. First, it will be pending. So I'll go ahead and then okay, I got a message in my inbox and then I'm clicking on confirm subscription. So it says subscription confirmed, which is good. So the next thing what we will do is whenever I publish something to that topic, it has to go in as a message, right? So I'll do this by 101 publish. It has a message called client terminal. So I'll publish this one. Okay, now this has got published, which means it should have gone to IoT Core. The IoT Core should have triggered this one. Successfully created. I have to enable this as well. Okay. Now the IoT Core will have triggered this rule, and then this rule will have triggered the SNS topic, and then I should receive an email. Since I didn't enable it, I'll do it again. Okay, so I have received messages. First message, it was like to confirm the subscription, and then I have got two messages, both of which has like only client terminal. I'll do one terminal once again. So you will see like as soon as I publish it, here I will get one more message here that should have the value client is terminal once again. From SMS publish. Okay. Here I have got it, which says like client terminal once again. So this is how we can trigger an SNS topic. Now, triggering the SNS topic does not make sure that we have stored the data, but we know DynamoDB, it's like one of the simplest NoSQL database or very powerful NoSQL database where we can store the data as well. So I'll quickly create a DynamoDB table and show you how we can store this data persistently. So I'm going to DynamoDB and then create a table. Let's call this table as IoT data, and then let's say I have a primary key called client, and this is a string. Okay, create this one. Okay, so I can come back to this one now, and then I can create that rule. I can say create the rule. DynamoDB, and then let's say any message that comes to bulb 101 publish topic, I want it to get stored. So I can click on split message into multiple columns and insert it into DynamoDB. So I'll click on that. Configure action. I need to select which DynamoDB table. So it's IoT data. And then I'll create a role. So IoT Core DynamoDB. Create the role. And then select it. And then I'll go ahead and then create the rule. Okay, the action field because input is not valid. Okay, it hadn't created that role, that's why it had the problem. Within a few seconds this got working. Now anyway, I can come back. Okay, I'll enable this one, and then I'll go back to DynamoDB. I'll click on items. Currently there are no items, so I will publish this again, and it should have gone to IoT Core. That should have triggered the rule, and then that rule should have put the data here. So if I refresh it, I think like that was not a valid message. So I'll have to put this. This will be like a valid JSON now. So here it has passed the JSON, and then it is putting terminal once again. And then I can have like other values as well. For example, I can say user, let's say reskill. So I'm having like two key value pairs. Now if I send it, it will have a new field called user, and then it has reskill in it. Because the client ID didn't change, it has overwritten that, because that's how the DynamoDB tables work. Anyway, so this is how you can understand about like how can you work with rules, device shadows. I'll not be demonstrating device shadows in interest of time, but you got the idea of how we can have device shadows. The thing about device shadow is that whenever you want to update the device's shadow, you will have to publish message in a specific topic. When you do that, it automatically gets stored as the device shadow. You can like know more about it when you click on manage things, and then when you click on bulb 101, and there is this shadows. By default it creates something called as a classic shadow. So here this was the desired state, this is the state reported, and whatever was the metadata of it, like the last updated timestamp, reported timestamp, all of those things. But the topic in which you have to publish so that the device shadow gets updated, you can find more information about it here. When you click on learn more, it will basically give you an idea about which topic should you be publishing it into. Here it is like AWS things, and then whatever was the thing name, and then slash shadow update delta, and then it will update it there.